You're listening to Cultivation Elevated, hosted by Michael Williamson and Anders Peterson, where we discuss vertical farming and the future of cannabis and food production.
Hey, what's going on, everyone? From Pip Horticulture, I'm Michael Williamson, along with Anders Peterson, and you are listening to Cultivation Elevated, the podcast where we dive into all things cannabis, food crops, CEA, and vertical farming. Today, we're excited to share some insights on CO2 design, and we have a guest here today, David Goodnack. Thank you for being with us with Plant CO2.
Thanks, guys.
You know, before we dive deep, I think it's important to start with the basics and fundamental principles. So, can you kind of highlight, I guess, why is CO2 important, and what are some of the general concepts of designing a CO2 system? Whether that's for, let's start with a commercial setting, and maybe we can talk a bit about some residential applications as well.
Yeah, typically when I'm talking to growers, educating growers, we're starting from growers who may have had a scaled back understanding of CO2, where it's 50-pound cylinders of CO2, and they've got, smaller, more, residential or grow tent oriented CO2 regulators. That's the system they're used to. As we step up to commercial, we're dealing with everything but just at scale. So larger bulk CO2 tanks that aren't filled with gas CO2 anymore, just because gas CO2 is pretty inefficient to transport around. We're now dealing with liquid CO2. So instead of just being a high pressure cylinder, we're now dealing with a vacuum jacketed cryogenic tank, meaning it's just holding a liquid that's at negative 120 degrees. There's some infrastructure and cost to that, but transporting liquid CO2, where most of the cost comes from the transportation, you're filling it up, it's storing in a big vessel outside. That's the only difference. So they're not rotating in cylinders. They've got a big bulk CO2 tank that sits outside. Inside the building, the principles are really the same. You're just transporting it, via some pipes, dumping it into the room. There's obviously some strategies around distribution and how we inject and how we make sure we get proper PPMs and we don't have microclimates in the room, more for the commercial side. Basic principles of CO2. I kind of fall back to, are you guys familiar with the laws of, or the limiting laws of, how do I fix that one?
Are you referring
laws
to
of,
laws of minimum?
yes, exactly.
Justice von Liebig's law of the minimum. It refers
That's
to
exactly.
plant nutrition, but that same concept can be used in a lot of other things. What's the limiting factor to plant growth?
Exactly. So all things optimize. If you take CO2 out and you just have ambient air, CO2 will be the limiting factor. As you add CO2, boy, you can gain about 30% increase in yield, assuming everything else is optimized. This is where people get it wrong, right? They have, okay, I'm going to pump it full of CO2 and I might be lacking on lighting or HVAC. So why am I not getting 30% increase in yields? Well, it's because there's something else that's the limiting factor there, right? Could be lighting, could be nutrients, could be a messy, unstable environment. So I always look at that. So that's what we're doing is anytime you're adding CO2, we're just removing CO2 as the barrier for the limiting factor of growth. So you may get 30%, you may get more, you may only get 10% if something else is the limiting factor there.
Yeah, and for listeners too, who are maybe new to cultivation or kind of getting started with growing, atmospheric concentration of CO2 is around 400 to 450 parts per million. So when you walk outside on a nice day, that's about how much CO2 is in the air. In an indoor plant environment with especially a crop like cannabis, that's a very high light crop that can take in a significant amount of CO2. By increasing that part per million threshold, like David's talking about, we can speed up the growth rate and pack in more bulk to your plant faster. I mean, when you see a cannabis plant grow and there's a new leaf and there's more stalk, that's physically the carbon that the plant is taking in from CO2 in the atmosphere and using it as a building block. When you dry and cure a gram of bud at the end of the day, a significant portion of that bud is pure carbon. And I forget the exact amount, but it's upwards of I think it's like 60% or something more. So oftentimes in grow rooms, we're supplementing 3 times atmospheric value to prevent it from being a limiting factor. So upwards of 1,200 parts per million or more. So it's
When we look at atmospheric as 400, right? Typically, when we design a commercial grow room, what we're doing is there's no outside air, or there's very limited outside air. It's just you're just exchanging like this. So when it's a sealed environment like that, you're not going to have 400 parts per million. Cannabis brings that down to next to nothing pretty quick during the daylight time. So that's why we're enriching with CO2. Now, in a greenhouse environment, you're cycling air through there, right? So you're maintaining that 400 parts per million. So less a detriment there. But anytime you do indoor, CO2 is pretty much required. Now, indoor growers that start with a tent, something like that, right? They're dealing with, do I use fermentation? Do I use grow bags? Do I do, some kind of burner? Any way to get CO2 in there? Or, do I go up to the cylinder, which is like the high tech, like home grower? When you get to a commercial scale, we're dealing with, you may still see some natural gas burners out there. I don't sell that equipment because no one buys it anymore. It dumps in heat, it dumps in moisture. If you don't maintain them, they can generate carbon monoxide. So it's not a system that, if you had any sort of investment money, you would go and you wouldn't put that in anymore. In greenhouses, you'll see typically a boiler system that may do under bench heating, something like that, and they'll pull CO2 gas off of the exhaust fumes. But even with that system, they really can't elevate the greenhouse more than 600 to 800 parts per million. And then during the summer months when they don't need a boiler, they heat up hot water in tanks and they store it for nighttime. But then they have a heat rejection unit, which is essentially just a heat exchanger where they're dumping heat outside to make up for, having to run those boilers to generate that CO2. So even in greenhouse, I just did a big project in St. Louis, 90,000 square feet of greenhouse. They're adding liquid CO2 in. And when we ran the ROI numbers, it was just through the roof. They would pay for this even though it was expensive to add CO2, liquid CO2 to a 90,000 square foot greenhouse, which is pretty leaky environment, right? A lot of CO2 is going to be displaced and wasted. They were paying it off within like half a crop cycle just because they had so much flowering space.
And that's not a sealed greenhouse?
It was a sealed greenhouse.
Semi-posi, yeah.
They had HVAC, things like that, but they still had ridge fence. They still had exhaust fans. So there's going to be leakage through that environment.
Well, so I think that's important, though, is that there are other ways to enrich growing environments, whether that's a greenhouse or an indoor, with CO2. But for commercial indoor cannabis growers, it seems like the industry has moved towards these bulk liquid CO2 tanks for an obvious reason. Cost, accuracy, the precision at which you can dose that into a room, and convenience. I think it's consistent. As long as you can get that truck to fill up your tank and your sensors are calibrated in your room, you're going to get that supplemented CO2. I'd like to touch on a little bit. So all three of us, right, we've been lucky enough in our careers to be involved in the design and build out of quite a few facilities around the country in our past roles and our current roles, et cetera. Previously, for me, I worked at an HVAC company designing HVAC systems for indoor cannabis grows. And David, that's where we met years ago, maybe 4 years ago or something. You were at a different company then, but I think we both, working on those projects, saw a scope gap. And, a scope gap meaning there's a lot of individuals involved in the construction and design and architectural and engineering of these projects. And there are a lot of different systems and, responsibilities that need to be handled by these various people in a project. One area of an indoor cultivation facility that often no one raised their hand and said, I'll cover that, I know exactly how to take charge of that system, was CO2. I'll give my perspective on how a lot of those projects went, and I think that will highlight why you started your company, plantco2.com. So from an HVAC perspective, right, we were controlling the climate. And oftentimes CO2 is coupled into that climate control system. When a customer wanted to design and source a CO2 supplementation system, they would often reach out to one of the major gas suppliers. You would probably think of Airgas as being one of the top ones, or Praxair, and there's a couple others. And these are industrial, massive companies that supply everything from the CO2 at your McDonald's to pharmaceutical grade research gases to pharmaceutical manufacturing firms and universities. And so to them, this is just another industry that they have the gas and they're going to serve it. The problem was that what we experienced was, a company like that would maybe or may not have the knowledge to size that tank. So how much CO2 do you actually need for a facility? How big of a tank? And then once you get that tank, how is it going to be distributed and supplemented into those individual grow rooms? Well, they just said, I'm not going to touch that. They said, look, I will size a tank for you, kind of guessing on how much CO2 you need, oftentimes oversizing that tank. They said, okay, we'll help you with the engineering of placing that tank outside your building, but we're not going to touch anything or really give you much advice on what to do once that CO2 enters your building. So from there, as a cannabis grower, you have to work with your mechanical engineer, your MEP engineer typically, to draw out those lines, come up with all the safety measures, and figure out how it's going to be controlled and dispersed to a set point in all of these various areas. That is where the scope gap ultimately, grew. Was some mechanical engineers just didn't know how to do it. They weren't familiar with these systems. Beyond that, they didn't know where to source the panels to actually do the individual dosing in each rooms. And then the biggest area of scope gap I saw was CO2 life safety systems. So because we are elevating the CO2 levels in these rooms by code, building codes, we have to have a way to ensure that it's a safe environment for your staff. And there was a lot of, oh, I don't touch that. I don't touch that. In comes plantco2.com. So how did I do? I mean, is that the scenario that you saw too? Maybe that was too much of a rant, but
No,
it was
if
clear.
I had known that, I knew a tenth of that when I started this company. I worked at a controls company. We had to integrate to all of the different systems in the space. And when it came to CO2, everyone was bringing me these little 120 volt plug-in right off the bottle. And it was max flow rate of 15 SCFH. To give you an example, my manifolds go up to 200 SCFH, which is rated for a 2,500 square foot room. So you can go onto the manufacturer's website and look it up. It's made for like a 10 by 10 grow tent. Mm-hmm. So this company was started out of frustration. I couldn't figure out why no one could find the right equipment. So I spent literally a weekend Googling this stuff, trying to find a manifold that existed on the market. And I even went to my buddy who worked at that company and said, hey, start this company. It's a winner. There's nothing out there. And he goes, I don't want to start the company. And I said, okay, fine. So I started manufacturing these manifolds, and I started with 20 of them. They sold. Made another batch of 100. They sold, then 200. And I was like, okay, there's something here. So when I quit my job and actually went 100% on this company, that's when I realized everything else was missing. So no one knew how to size the CO2 tanks. No one knew how much CO2 was actually needed. So customers would come to me and say, hey, can you provide this for me? Engineers would come to me, consultants would come to me. So I knew I had to build out the calculations, and I did that through, going through everything. And then as I started getting tank data in, I started updating those and until where I'm at now, where I am pretty dang spot on. I mean, if you have drywall walls, I can't help you there. You're going to use more CO2 than someone that has, DPS panels and it's all sealed. But I started adding scope in, trying to address all these issues. So I now do stamped CO2 engineering drawings, which MEP engineers are capable of doing, but they don't want to. It's liability. It's an expertise gap that they do general MEP. Maybe they specialize in some cultivation facilities, but CO2 is kind of a real specialized niche, and it's a real small part of their project. So when they meet someone
and
like
oftentimes too, these engineers are already doing a lot of firsts on these projects. You
Oh
know,
yeah.
it's one other kind of question mark in the head where like I just don't want to deal with that. I'm already dealing with so much other new engineering tasks that I've never done before.
100%. So I started steamrolling, kind of picking up more and more scope just out of like necessity of like, hey, you want this project, you also got to provide our CO2 tank and supply. So I started kind of gathering in the scope to where I'm at now, where someone meets me, they give me their facility layouts. I've automated everything. So within 5 minutes, I can give you your CO2 usage. I'll size your tank. I'll explain why I chose this tank over this one based on pricing. You're in the middle of nowhere. There might be a snowstorm, not based on the tanks I got sitting out, in the old warehouse or something in the laydown yard. Um, and then I'll say, here's your quote, and I have that within 5 minutes. And once they pay me, I put together the stamped CO2 drawings they can submit for permits. And then here's all the wiring diagrams you need. So my background of mechanical engineering, which let me manufacture the manifold and all of that. And then I've got 15 years of controls experience. So I put together a complete package of, okay, this integrates with your exhaust fan. This integrates with the safety shutoff valves. This is how this is going to integrate to your cultivation control system. All of that's already well thought out. So it's a complete turnkey solution with wiring diagrams, with all the questions you have answered. So if I get a question from someone, how do I put a video together? How do I put something together so that they don't ask me that question again? So that's just been the process of the business so far of what else does someone need? And I think I've got most of it, but I'm sure there's going to be something next that someone asks me for. I'm like, yeah, I can do that too.
See that point you just made of you've already thought out all the integrations because these CO2 systems, it's amazing how they spider out and touch so many other systems in the facility that
Yep.
you wouldn't really think of at face value. That's where in the past, in a lot of these projects, people would say, I'm not going to land that wire on that terminal. It's not my
Yep.
responsibility. I don't know where exactly to, or that's not my equipment. And that's where you got people literally being like, the whole CO2 system's installed, but this other guy has to come land that wire. It was crazy to me.
100%. So I kind of wrangle everyone together. I have the wiring diagram, and what I'll do is I'll have the plumber on the phone, I'll have the low voltage guy, and I'll have the electrician on the phone. And it's a 10-20 minute conversation, but having everything laid out and lined out and saying, you're going to do this, you're going to do this, you're going to do this. Any questions? Everyone's like, oh, it's super easy, right? Especially when the owner's on the phone. Oh, that's super easy. And then they take responsibility and it gets done. And they've got my cell phone, so anything happens. Yeah, yep, land the wire right there. Yep, change it to this terminal. Super easy.
One of my frustrations with some of the larger CO2 companies, besides a lot of what was stated here, was simply the duration of the lease of the tanks. You start
Mhm.
talking about typically, I want to say it was like a 7-year lease. And 7 years in the cannabis space it seems like forever. And so being able to commit to something like that was always a challenge for me personally. And, you kind of have to, I did learn after time that you can negotiate those. But that all being said, I guess, what are you guys doing how does it work if I'm a customer? Do I own the tank? Do I rent the tank from you? If you can kind of break some of that down for me.
Yeah, great questions. Yes, you can purchase the tank. However, it's not as advantageous as you might think. So I work with the independent market. There's the big market, which is your Lindy, your Airgas, your Praxair, those guys. There's the independent market that's kind of like a bunch of small family-owned CO2 companies that may have, one office that does welding shops, or it may have, 20 offices across the US. So I work with that market. You typically get much better delivery. You get much better service. You get sometimes better pricing. And I say sometimes because the big guys, when they're trying to get you to sign the contract, they have the money to say, we're going to take a loss for the first 6 months and give you some screaming deal, almost like when you're, picking out, an internet provider. You see that, oh, $30 a month for a year. You're like, ah, great. And they start, once they have you in there for that 7-year contract, they ratchet up. They are not going to lose money. They have shareholders. They're not in the business to lose money. So the independent market will come to the table saying, this is how much it needs to be for me to sustain and make money. And the bigger guys will come in and say, oh, look at this low price. And within a year, they're here. And within 2 years, they're up here. So these guys will come in with 16%, 20% increases per year. Now, to answer your question, these tanks are expensive. So if I put a 6-ton tank in, that's roughly $90,000 for that cryogenic tank. So my scope comes at the tail end of the project. Most people at that point are over budget. They just need to get something going. They just need some revenue. So they're not looking to shell that out. The way CO2 companies make money is they make money off the tank rental. They make money off the CO2. And the price per pound is like, it changes based on, 20 cents a pound to 50 cents a pound for most bulk applications based on how remote are you? The cost is really not in the CO2 molecule itself. It's in the distribution. It's in the transportation. How far does a truck have to go? And when they get to you, are they dumping a full truckload? Are they dumping a little bit of the truck? That all affects the cost, right? That's where all the cost of CO2 comes into. So when you look at these terms of contracts, 7 to 10 years is kind of standard. We go to a 5-year contract. And the way our tank pricing is, we're trying to pay off our tank in about 5 to 6 years. So if you look at the cost of the tank, divide that by 6 years, you're pretty much going to get our pricing for, per month. So if you fulfill that full 5-year contract, and then resign, we have a chance of breaking even and making money. That's the way the business works. And on the CO2 price, we're probably making 1 to 2 cents a pound.
Yeah, my understanding the margins on the gas itself really aren't there. It's in the rental.
It is. So if you go and say, I'm going to buy this tank, that's great. But that's no longer a place where I can make a little bit of money. So we have to increase the price per pound of CO2 to make up and pay for all that distribution costs. It's kind of a game where what does the customer look at? Is it the price per pound? Is it the tank? But between the two, that's how we pay our bills. So, we're going to increase this by, $200 a month, and we're going to drop our CO2 price by 5 cents a pound. If you're really concerned about that, or if you say, instead of a 7-year contract, I want a 5, that's fine. But your monthly price, your monthly cost for that tank will go up because everyone's playing the same game. Unless they're pulling a tank from their, a stockyard. And if they're doing that, it's not going to be, so like our tanks are brand new, they're vacuum jacketed, kind of like a hydro flask. The reason this matters, you've got CO2 at negative 120 degrees in here, right? So as it starts to warm up in the sun, it starts to boil off and create gas pressure. These tanks typically are set to about 350 PSI. So anything over that, it starts venting out and you start losing product. These tanks, the brand new ones, they can sit in the sun for 45 days, won't lose any product.
Nice.
And with cannabis, you're sipping off this tank. You're not a heavy user, you're a constant user. You're always sipping off this tank. So this thing never needs refrigeration. You never will have CO2 loss because it's perfect for the application. When you go to an older style tank, it's a metal vessel with like foam insulation around it. Think of it like you go to the store and get one of those temporary styrofoam igloo coolers, right?
That don't work.
that don't work. So what they do, especially if it's an old tank with kind of packed down insulation, they have to have a big compressor that's always running refrigerant through there trying to keep that cold. And even then, you may still lose a little CO2. We've got one in Arizona that's just, it's a competitor's tank and it runs 24/7, plus it leaks CO2 out. So think of the cost there. It's a 480 volt compressor typically. You're probably going to spend a couple $100 a month on electricity costs for that, and then the maintenance on the refrigeration. So last thing on differences on those big vendors versus small ones, right? We have a 5-year contract versus a 7. May not seem like that big of a difference. However, let's say cannabis customer goes out of business or sells the company to a different LLC, different entity, right? For us, great. You went out of business. That's on us. We come pick up the tank. We try to use it for another project if you have 3 years left on the contract. The big guys, if you go and your company goes out of business, guess what? They want to get paid for that full 7 years on their contract, and they're going to get their money. Or you sell to someone else, they want their money. So read the contracts
And they
carefully.
likely will start that 7-year contract over again if the entity changes. If you sell the facility and it's a
Exactly.
new
I've seen
entity
that
on
too.
I've seen that too, where all of a sudden
Hmm.
now it's a new 7 years. Same equipment, they did nothing. They just are starting the clock over.
Exactly. So the typical game is they come in super low with pricing. They ratchet you up until it's like painful at that end of the 7 years. And there's time to negotiate. Guess what? They already have a big vessel. It's already piped in. So what they'll do is they'll renegotiate down to here. And then they just start ratcheting you up again. And oh, you're going to change? Okay. So it's a game. So when you deal with a company like myself, we come in at the price we need to come in at. Our price increases are what they need to be to cover uh, driver wage increases, cost of transportation increases, maintenance on the trucks, things like that. So it's predictable.
You've said
Hey,
a bunch of things I want to touch base on, but and
me
I want to
too. Go
acknowledge this
ahead.
comment. Sorry, yeah, we'll do one and one, Anders. I want to first acknowledge this comment that you made earlier about you created this company out of frustration, and I think that's some of the best companies are built out of frustration. Some people start a company because they saw someone else doing something, and they're like, I could do that, right? And they're just looking at it like from a monetary standpoint, and there isn't that connection to solving a problem. And so I think it's pretty awesome that, and it's unfortunate, but if you get mad enough at something and you realize that something doesn't exist and you have the skills and resources to bring it to life and the stones to do so, it's where a lot of really incredible things happen. So I like frustration. It's like a catalyst for innovation and like entrepreneurship. But to me, it's mind-boggling. The comment you made earlier is like, oh, CO2 is like an afterthought. And I'm trying to give like a comparison for like someone who maybe doesn't work in controlled environment agriculture, but it'd be like
Yep.
if you were like, I'm gonna build a space station, and oh yeah, I need oxygen too, you
We'll
know?
That's a
just
great analogy.
Oh, I forgot. We need oxygen to like make it actually perform well. People will die. The plants will survive obviously without CO2, but it's a resilient plant, right? But survival is not thriving, and getting a plant to survive that does not equate to survival of your cannabis company in these challenging and consolidating markets. So, it's mind-boggling to me that that's the case. Why
it,
do you think that is? Where's the disconnect? Is it education? Like,
CO2 isn't sexy. I've thought of every way I can to make CO2 sexy, and boy, I don't know if I'll ever get there. Um,
mobile racking isn't sexy, you know?
I agree. Airflow solutions aren't sexy.
Hmm.
But if you look at a grower, and anytime I talk to them and say, what else do you need? What are you looking for? They already have lights picked out, and guess what? They've been picked out for months, and they've been dreaming about the Instagram stories are reading about their lights and how it's going to make the facility boom. If you don't have a balanced HVAC system, if you don't have airflow, if you don't have the nutrients and CO2, I don't care how good your lights are. So I would rather have mediocre stuff that's balanced across the board versus I paid $1 million for this light and, skimped
Hmm.
on everything else to have it. Um, so I don't think many people will understand that because a lot of these people that I'm talking to, growers, facility owners, this is all new to them. So they're either getting their information from a grower who may have started something smaller. This is probably the biggest commercial facility they've ever, designed, operated, owned. They're dealing with engineers who this might be their first facility, or they've got a couple of their kind of following that blueprint, but man, there's a huge knowledge gap, and that's exactly what it is. And CO2 is something they say, I'll wait to the very end, and I'm going to reach out to the local supplier, and they're going to hook us up with it.
Well, and it's
But
like it's like I've been through this in projects too. Earlier in my career, I'm like, I don't know who to call. When it comes
Yep.
to lighting and nutrition and those kind of things, it's like I know who to call because I see them every day on Instagram. I saw them in the magazines, I saw them on the websites, I saw them at
Mhm.
conventions, whatever. But it's like, who do I call for CO2?
Yep.
If you're kind of new to this, it's a challenge.
And the reason I don't think there's many companies like me out there or Plant CO2 out there is okay, lighting. You sell lighting to a facility. That's $500,000. That's $1 million. If I sell CO2 to a facility, it's probably ten to $20,000 of equipment. They're very small, so I've got to sell to 100 different facilities to come close to what that lighting company does for, 5, 10 facilities. So it's completely different. And I'm lucky that my competitors right now are, big gas companies or small gas companies that are used to doing bars and restaurants. You're right.
Mm.
They're used to 750-pound tanks and they know exactly what they need to put in that gas station for that soda machine. They get to cannabis and they said, we'll put a 12-ton tank in there. You'll be totally set when they need maybe 3 tons of CO2 storage or 2,000, something much smaller.
That is one of the questions I had. Well, so I think from our conversations over the years, like I know that, and you know, cannabis grows use food grade CO2 gas,
Mhm.
right? So it's the same CO2 that, you would be using in a vending machine or like a soda machine at a restaurant. It's food grade. Where does that gas come from?
Yeah.
And how, and
So
I'm sure the production or capture of it changes the cost per pound, you know, pretty frequently. So can you speak on that a little bit?
Yeah, CO2 generally it's a byproduct from an ethanol facility, a ammonia facility. Sometimes it comes out of a well or it's comes out with another gas and they separate it. Um, so when you look at purities, plants don't need grade gas, right? They don't care. They just need elevated CO2. But when you look at, okay, beverage grade gas is 99.95% pure. So you've got 0.05% of purities. If you back it down to industrial gas, you've got more impurities. When the impurities come from an ethanol plant, okay, that makes a difference, right? What those impurities are. So the plants don't care. It's more of the equipment gets messed up pretty quick.
Mm.
All the valves, the regulators, things like that, having those extra impurities from like a welding gas or industrial gas, you'll be going through those things and be replacing them quite frequently. It's very harsh on the equipment. So that's why we use beverage grade gas. It's for the equipment's sake, not for the plant's sake. Um, I also distribute direct air capture machines, which pull CO2 out of the air into an absorbent. They isolate the chamber, they pull a vacuum on it, they add heat to release the CO2, and they put it into a tank. Generally that CO2 is 70% pure, which is totally fine because the other impurities come from the air around us. Doesn't matter. And when you're releasing CO2 that's 70% pure into the space, it's still going to enrich the environment just fine. Uh, so, man, when you get in the CO2 space, you go pretty deep and you learn a lot that, into this black box that I never knew before or wanted to know before.
Yeah, I would agree. I remember when I learned there was different grades of CO2 as you were discussing. And even with the beverage grade, there's obviously some kind of petrochemical somewhere in there. If you ever look at like maybe the back lines of like a soda machine and they have that like back run of oil or if they're not maintaining things, it's always made me question, like, oh, okay, like how does that impact plants? I don't know that we see anything from that. Even, when you have machines that can grab atmospheric CO2 or create CO2, I guess the impurities from the atmosphere would make me more nervous than the impurities from like another bulk tank provider. Just not knowing what's in the air. I guess is it because it's so cold that it kills some of these things? But like, let's say you were in an agricultural area and you were,
Oh, I see what you're saying.
yeah. I have a lot of questions there. I'm like, I wonder. I guess from your side, what are like the pros and cons or risks and reward between those two approaches to injecting CO2 into your site?
Direct air capture is very new.
Mm-hmm.
So this was like a NASA technology they used for like scrubbers and cleaning the air up there. Um, Man, I'm not sure. So you're saying if I was collecting CO2 into the sorbent, released it, could pathogens, could, all the bad stuff be injected in? You're right. And that CO2 is not liquefied. It's not stored at negative 120. It's probably room temperature sitting in almost like an air compressor style tank
Mm-hmm.
that they use as a buffer tank. So I'm not sure we know enough yet to know what's in that CO2 and impurities.
Because
I haven't implemented
logically, when you
those.
talk about costs and like truckloads and distance and all that stuff, like a direct air capture sounds attractive without knowing all the
Mm-hmm.
details. Obviously, not knowing the cost and all that stuff. But how do those two applications, if we take away well, I guess if we accept the fact there's more that we need to understand as a community about the risks and rewards there. But if you were to look at it from a financial standpoint, how do the two kind of sit? Are they shoulder to shoulder, or does one just make a lot more sense than the other currently?
Yeah, I represent a direct air capture company because I believe in the future it will
Hmm.
be economical. We're not there yet.
Okay.
So when you look at liquid CO2, I've got a bulk storage vessel that has no moving parts. I pipe it in through copper piping, and I have one solenoid valve that opens and shuts. That's my only moving part in the whole system. So it is very reliable. The customer pays a monthly fee. They don't pay for that tank. So let's say the tank comes on site, they start paying $800 a month or $1,000 a month. Okay, that's their only cost. They have some sort of equipment cost, but after that, it goes with the capital flow. And okay, I've got revenue coming in from the plant. Now I can start paying the CO2 bills. It fits very well. Direct air capture, typically it's okay. I shell out $50 to $100,000 up front for the equipment. You have to get in front of it because it uses a lot of electricity. It uses like space, so
Mm,
it has to be engineered and designed into your plan very early on, which CO2, as we know, comes in at the very end of the project. And then uh, the electricity needs to be cheap enough to make it, so right now um, it was 4 kilowatts. Last time I checked, it was 4 kilowatts per kilogram of CO2 to be produced.
Wow.
So it's got to be in a cheap area for that to make sense. So California makes a lot of sense. They have a lot of trouble with CO2 supply, and they've got a plant that's getting ready to shut down this summer, and there's going to be big shortages in California. However, the cost of electricity is also very high. So unless you've got it powered by solar or something like that, direct air captures it will be a solution that I'll be using in the next 3 years. But right now, when I compare the two solutions, these growers are they have $10 million. They're trying to build a $20 million facility. So you know what I mean? They're not going to
sure.
want to invest in a CO2 capture machine that may make sense in 3 years. It also has filters that you have to swap in and out. That
Mm-hmm.
Sorbent only lasts so long. So there's a reoccurring monthly fee with that as well. So when you add all that up, right now it doesn't make sense for me, and that's why I specialize in liquid CO2. But I am up to date on all the direct air capture, and as soon as it becomes viable for cannabis customers or others, I'll start using that solution.
I've seen a lot of people look at a lot of interesting ways to capture or deliver CO2 in a different way than just buying it on a tank and filling up a bulk liquid CO2 tank. I remember there was a pilot program in Denver, Colorado, where a grow was co-located next to a brewery. And they wanted to capture the CO2 from the fermentation at the brewery next door and pipe it over to the grow. I thought that was amazing. I believe that there was some sort of limiting factor and it didn't work as well as they liked, but it's really a creative use of co-location. And I think for vertical farming with cannabis and beyond, leafies and vegetables, just any indoor vertical farm or indoor agriculture, co-location is going to become more and more important with other businesses. I know they're already talking about even getting USDA federal funding to get, farm parks like an office park. And so, can
Mm,
your business and other businesses benefit from economies of scale by all being co-located? They do
Cool.
that. They do that in the Netherlands quite a bit. In fact, there's another interesting CO2 anecdote from the Netherlands where they had all these greenhouses these companies co-located and co-invested in a massive, combined heat and power, like trigeneration. So they're burning natural gas to spin a turbine to create hot water, cold water, to climate control their greenhouses. So they're off the utility grid, essentially. They are their own power plant. And as you mentioned earlier, you can also capture CO2 from that combustion process. So they had the same challenge though, where it wasn't enough CO2 for certain times of the year. In fact, the infrastructure was pretty amazing to look at. They capture it off of this, turbine essentially, and they filled this massive balloon looking structure, this big dome, structure that inflated with the CO2 that was post scrubbed. And then that was what was injected into the greenhouses. And so, but ultimately, they had to bring in some supplemental trucked liquid CO2 to make that project work. But they were able to, once they got the ROI from the capex of building their infrastructure, their recurring CO2 costs were much lower than their competitors. So there's a lot of it's going to be interesting to see where the future of CO2 in agriculture and horticulture goes. Is it going that direct air capture? Or are more people going to be doing, chilled water, hot water, or cogen, trigen, co-locating with fermentation? And I think about the explosion of mushroom cultivation facilities too, right? They basically work opposite of plants.
I've seen it in Nevada. There was two facilities. One was a mushroom grow, one was a cannabis, and they had a system where they were exchanging air underneath the parking lot, and they never got it to work. But it's these ideas, and I will always be an engineer first. So I am always about getting the best solution and kind of the business second, which is not the best for business, but it's really good for customers because I'm always trying to innovate and improve. So I love the cogen stuff. I think that will be something big in the future.
We couldn't make it work. We ran
Yeah.
cogen out in Salinas, California, in our greenhouses, and there was some really great intentions there, but we couldn't. It didn't make financial sense at that time.
Well, I
And
will
to your
say
point, we couldn't get enough.
there are a lot
Yeah.
more smaller turbines available today, even in the last couple of years for cogen and
Yep.
trigen. They're making smaller units that are more modular for the first time in history. And there's a lot more utility incentives for going that route too, especially because you're now a power generator and you can sell back to the grid. So,
Yep.
especially in a place like California, New York, I know was quite big on the incentives for it. There's a lot of options, but I hear you. In the past, it's been very hard to make it work financially for a lot of indoor growers.
It's like when you get a customer who's like, "We're gonna be a solar cannabis farm," and you're like, "No, you're not." Like,
Yeah.
like how much land do you like? People really underestimate how much
Yeah.
physical acreage you need, what kind of solar farm you would need, and how high intensity the energy consumption rates are on these facilities. So, but yeah,
Hmm.
see, this is yeah. I never know when we talk about when we pick one topic like CO2. It's like, all right, how much is there to talk about CO2? And now I'm realizing we probably have to do a part two episode on CO2, which is also exciting. I've noticed this connection, and I'm curious. This is kind of more of a personal question. I grew up with engineers when I went to school in Florida at UCF, and they were a combination of engineers and surfers. And so I feel like
Hmm.
there's this correlation between the two, and maybe it's just the irony of the bubble, but you share this passion as well. And I was curious to know, like, what is it? What is it about those two things? And another oddball example is like some of the best cannabis breeders I know are also some of the best dog breeders as well. And so there's these like they're like parallel paths that tend to kind of run with certain folks. And so it was interesting when you were like, "Hey, I'm down." I can't remember you said Nicaragua or you were traveling around surfing, and I was like, "Man, these engineers and surfing, it's just there's something there. There's something about it."
The funny thing is, I went to school with a lot of engineers, and man, it's a different breed of people that are engineers. And I think the reason why I was able to do sales and run a business is I'm probably a bad engineer, like on the spectrum of good engineer, non-social, bad engineer, very social. I'm probably on more of this scale where I'm still an engineer, but man, I'm probably not the smartest guy in the class. Um, that gets me to being in sales. And be honest, right after school, I started doing automation and sales jobs and things like that. Realized that's kind of where the income was.
Sure.
Um, the surfing thing, I am not a surfer, man. I still suck at surfing. I've been doing this learning this surfing thing, and I'm still horrible.
Yeah, you're good. They say it's not your first 20 years, it's your second 20 years that you learn how to
Oh,
really surf, you know?
the way this works, my girlfriend's over there, and that's why I'm here learning how to surf. Is she was a really good surfer and said you have to learn how to surf, and I said that's fine. I said my passion was skydiving. You have to learn how to skydive. So in May, we will be out in California for a full month, living at the skydiving center as she learns. The goal
Nice.
is at least 50 skydives so that she can jump out of a hot air balloon with me by the end of it. So
Oh
Nice.
man, I'm
that's
gonna
the
have to
goal.
meet
Yeah.
up with you. I live here in
Yeah.
California, and I've always wanted to go skydiving, so I may have to meet up with you and your girlfriend. You take me on a jump.
I am a tandem instructor, so technically I could take
Strap
you
me
on
to
the
your
plane.
back, buddy. Let's go.
Yeah, just some trust building. Anders knows this about me. I'm afraid of heights, and I've been trying to get over it my whole life. And so, logically, I'm like, well, if I can jump out of some airplanes, that should do it. And so I've jumped out of a few airplanes now, four, and I've used it as a kind of on backpacking and traveling, when I was younger as like an experience to do in Switzerland or in Colorado, or, you can jump in the center of Florida here, and on a clear day, you can see both coastlines, which is pretty cool.
That would be
Um,
cool.
but that being said, still terrified of heights. And so I've been trying to figure out, like, I thought for sure skydiving would be like that, I don't know, golden ticket to overcome the
Rock
fear.
climbing. You have to
Oh,
do rock climbing, and you have to do lead climbing. That is so. I'm afraid of heights as well, and I discovered through skydiving that you're so high up that it takes that fear away. And by the time you're low enough to see the ground like really clearly, you're under a parachute.
and you got a bunch of adrenaline pumping and dumping, and
Yeah, well, not anymore. I've got 800 jumps, so I'll like be eating a hot dog and backflip out of the plane and heart rates like this. Um, but lead climbing, knowing that I could fall that 5 feet before the rope catches me, I'm shaking. I'm turning chalk into like pancake batter as I'm just like sweating.
sweating. Yeah,
Oh, that's the ticket.
yeah,
Crazy.
nice. That's fun. We could have started with that one, but I thought we would
Yeah.
kind of wrap up the podcast with just some personal stuff, and yeah, that's really interesting.
Yeah, I could probably ask you about a million more questions in my head around CO2, but maybe that's a good excuse to have you on again and we can dive more into it.
Yeah, definitely. And for our
Yeah,
listeners out there, oh, sorry, go ahead, David.
I was going to say it might be helpful in the future for me to like pull up an example project. We'll walk through it together as far as CO2 usage, sizing, the equipment you need, just to kind of show them the process. Everyone puts this in at the tail end of the project. They don't realize there's design, there's lead times on the tank. You need to get permitting. And so that could be a week, that could be 6 months based on where you're at. So CO2 is something to get involved early in the design because submit those permits, get them, have your engineers or have your engineers put it into the project, have your trades have the scope of like, oh, I've got to also install CO2 piping instead of having the add-ons that's going to cost you later in the future.
Awesome. Well, yeah, for our listeners, David's really easy to get a hold of. PlantCO2.com, very personable. If you are at a cannabis trade show, look for the giant, was it neon yellow shirt that says "Ask me about CO2" on the back. But yeah, and also as you guys are listening to this podcast and have any questions, feel free to drop them in the comments. And David, how do people get a hold of you?
Yep. Website's the best. Sales at plantco2.com. That's on the website as well. My number's on there. So I give you like 3 avenues to reach out. And typically I can respond within a few hours, get you a quote within 24 hours. I don't think anyone else can say that.
That's rare. Yeah,
Yeah.
very rare.
Well,
Very
David, it's
cool.
always a pleasure talking to you, man. I always enjoy chatting with you and hope you're enjoying your time down there in Costa Rica and looking forward to your time here in California. Jump out of the plane with me.
I'll see you boys soon.
All right.
Yeah, man.
Thanks, guys.
Thanks, David.
All right.